All right, we're just getting set up, looking at the sun today. Just give me just a minute. Try to make sure this stream is set up and actually streaming. So just give me just a minute. Oh, now we're having the internet issues. Hang on. Let's figure this out. Can I locate Atlas? No, not at the moment. Trying to, well, right now we're using Starlink as the internet, and right now it's not doing very well today. So I'm trying to change some settings here. Just give me a minute. Hopefully we can get this streaming session going, but the internet is not working right now. Um, Give me just 1 second here and see if I can adjust some settings, and we'll go check out the sun in a little bit better detail. I may have to run inside and change the settings on the router. Um, 1 second. I'll be right back. Sorry, y'all. Just reset the router, so it should. Oh man, there goes a little bird going across there. All right. All right, let's give this a shot. All right, hopefully this is working now. Maybe it's working a little bit better. All right, let's see if I can get logged on here. All right, let's see here. Let me get this. I think we're back up. Let's see here. I can't get this YouTube channel thing pulled back up. Okay, all right. Okay, how about now? It says it's excellent, so hopefully we're back up and working now. Um, if anybody's here in the chat, hit me up with a thumbs up or something. Let me know that it's good to go now, and we'll start checking out the sun. Um, okay, awesome, awesome. All right, so what we're going to do is trying to beat the weather here. Oh man, I don't know. The sun is really messing with Starlink today. It gave us an excellent reading, and now it just switched over to poor. But anyway, we're going to keep drive on. We're going to see if we can't zoom in and let you see some of these really cool features here before it gets knocked out completely, because I really want y'all to be able to see what's going on in the sun today. Let's get zoomed in a little bit more here, and we'll get focused up. And I know this thing is lagging a little bit, so all right. There we go. That's much better there. All right. Sorry, I'm trying to keep the sun out of my face while I do this. Darken this up a little bit more contrast, so you can clearly see right now this really active sunspot area right here. It's a beautiful looking sunspot, well defined, and it also has some flare activity going on around it. This is the hotspot region, the active region. Here is a filament, and what this is the same as a prominence. The prominences are when you see it on the outer rim. Filaments are one of the same, but it's just because you're looking at it directly on. This in itself is a really huge filament. That's really big. Let's see here. Let's go around the rim and look and see what's going on with it today here. Oh, look at that. Look at all of those huge prominences. All right, let's get zoomed in so you can see a little bit better. There we go. Now this one right here is probably 150,000 kilometers high. And if I could, if the cursor was about the size of the Earth, maybe a little bit smaller, that's about the reference size that would be. So you could stack 5 or 6 Earths from the rim to the top of that prominence. That is really big. Let's see if we can't get up there a little closer. And don't know if we can zoom in around it a little better, but maybe I can try to tone it down a little bit so it's not so bad. There we go. How cool is that? That's really cool looking right there. That is pretty amazing. And I know that what I'm clicking on and what you're seeing has got about a 20-second delay. But that's just, I guess, the policies of how this works. But man, that is just incredible prominence today. There are some, and I just completed. I'm actually doing a test right now. Player One sent me their Apollo MMAX 428 Pro camera for some testing and comparisons because I've already previously bought the first two versions of the Apollo series, and now they sent me the Pro version to test to do a comparison. And by far, so far, I did a 2.5 hour time lapse this morning. It's incredible. I'll see if I can't get that processed and post it tomorrow. But wow, it's super active with these prominences going around the rim today. And there's some ever so slightly, I'm boosted up a little bit more. Look at that. Oh man, look at that. That's just incredible right there. This one's even larger and more intense than the other one. Look at those. Now let's see if I can bring the exposure down just a little bit. We'll get it exposed a little bit more here. You can see it in better definition here. That is just insane. The plasma coming up off of the sun and then coming back down in a time lapse, that's going to look amazing. Am I going live tomorrow? I don't know. We're probably going to have, I don't know what kind of weather we're going to have. So I'm not sure. I'll say it depends on the weather. That is just crazy. We've had some really crazy weather. So it really depends on the weather. All right, let's move on around a little bit. There's a little bit of active flare going on right there. Let's scroll down here a little bit. All right, let's see if we can't get this in a little bit better. Yeah, there we go. Look at that. It's really active today. I mean, it's really active. What's really cool is when you do this and you sit here and watch it for an hour or 2 hours, these prominences may grow a couple 100,000 kilometers or even a few thousand kilometers, and then they'll retract back in. Or it could be enough to where it would have, big, huge solar flare or even coronal mass ejection, which would be really cool to capture on a time lapse. Let's see what else is going on here. I got a couple little spurts coming out over here. All right, let's get back to the center. Let's tone this back down again. Bring it back into some viewable, capable viewing here. Let's get it boosted up just a little bit. All right, so now that we have the sun in full view, so again, what we have here are the active hotspot regions, the flare regions going on right here, this white area. The sunspots are the darker areas, and these long rope structures are the filaments. Now, these filaments are exactly what you just saw on the outside of the rim, which are prominences, but it's because we're looking at them straight on versus on the edge. And if we were to watch, if you will tune in and at least watch my solar time lapse that I'll hopefully get posted tomorrow, you'll be able to see these regions just doing some really cool stuff in a time lapse. And maybe even have some coronal rain where the sun's plasma is ejected up off of the surface and it goes up, but then it comes back down and it looks like rain. That's why they call it coronal rain. So let's get some more contrast to this so you can see a little bit better here of what we have going on. And then we'll boost up there There we go. And let's get zoomed in on one of these this area right here. Now let me get refocused. I'm gonna turn the gain down, because when you put a lot of gain in there, it really puts a lot of noise into the picture. So let me see if I can't get this focused up a little bit better. And the best way to focus is to put a lot of contrast in it, make it dark, zoom in on something that you can see, and then try to have a nice, crisp, clear picture, but as dark as it can be on your focus. So that's about as good as we're going to get the focus for now. It's constantly changing. Let's get this back where we had it. And now let's go look at that sunspot again. So as you can see, it's this sunspot here is really producing a lot of activity. And I'm imaging over the top of my house right now, so you can see the waviness. See how this all looks wavy? That's the heat and the atmosphere, the disturbance in the atmosphere coming up from above the house. It's not an ideal way to image, but it's the only way I can do it right now in the wintertime, being over top of the house. So that's why it's looking kind of grainy at the moment. Trying to tone that down. I'll tell you, let's say what, let's look at, this is what it looks like in black and white. And I'll show you what it looks like when we invert it. Sometimes that looks pretty cool. You can really see the differences in the area. So now the dark spots are the hot regions, and that's the flare regions going on, and the cooler spots are the white spots, which are now the sunspots. So what we've done is we've inverted it, and that just gives you a different perspective on the way that the sun looks. And let's see here if we can zoom in a little, kind of give you a little different perspective on how the sun looks. And these filaments go a long way. These things stretch thousands of miles. The entire Earth here, I mean, the entire sun, the circumference of the sun, if you could stack Earths in there, you could fit about 1 million Earths in the sun. That's how big this thing is. It's about 93 million miles on average away, and it's about 8.5 minutes for the light of the sun to reach Earth, give or take on what day of the week it is and where it is on its cycle of how far it is away, because it does have that cycle of where it gets average of 93 to maybe 94. I'm not sure the total distance, but it does move away from us and then it comes closer. All right, let's get zoomed in. See if we can't get focused up a little bit better on some of these inverted images here. That's about the best it's going to get right there. That's still pretty amazing. You can see that roped prominence right there, and this is actually lifted up off of the surface. So you could actually go underneath it like a bridge. This is tethered to the sun here. This is tethered to the sun here. But up in this bridge, it's underneath. It's probably 150,000 miles high, and you could go underneath it. That is pretty wild. All right, let's show you what it looks like from outside of the rim here. So if we were to go the other way, we can show you before we start clipping images. Now you can see it's inverted, and now you can see the prominences around the rim in a little different light. You can still see them all sticking out there. That's just saying that the sun is very, very, very active right now. Excuse me. That is really cool to see how that is. Let's see if we can, let's see if it'll let me focus in on that a little bit. That's probably it right there. You can see the plasma on the inside, the structure of how that looks. Look at the detailed structure on the inside there. You know, the forces of the sun and its of the magnetic I don't know what to say, the magnetic capabilities or just the magnetic forces that it has in pushing that plasma up is just amazing on how it can do that. That's just pretty cool looking there. And this one here is just ever so slightly. This would be coronal rain here, where it's coming up either side, whichever one it is on the time lapse, you'll be able to see it, where it comes up from the solar surface, shoots up into the atmosphere, and it gets drawn back down, and it falls back down like rain. And this process could go on for hours or weeks. It's really amazing to watch. All right, let's bring it back to our normal view here. So there is the black and white version of it. And like I say, we can contrast it up by pulling this slider back. And as you can see, you can watch it get more contrast to the solar surface. And you can start to see more of the sun's granules and filament features on the solar surface in this area here when you boost the contrast. And then now you can still see the active regions. You can still see that filament we were looking at earlier. And there it is right there. But look how much cooler it looks. And it's easier to spot when you add colorization. So all we did was just added some color to the sun, and we can make it lighter or darker to boost that contrast, to make it easier to see. It's not making it fake, it's just making it easier to see. We just focused it up a little bit better. But this is really the biggest active sunspot that's going on the sun today. There's a couple along the edge, and it's going to slowly rotate into view. There's a couple over here. Now this is oh man, if we could get this going. Let's see if I can get into there and get it focused. This right here, I don't know if you can see it. It starts right here, goes up and forms almost a perfect half circle. That thing is tethered on one end. It's a loop filament. And the reason we say it's a filament because this is the way we're looking at it. But if we were looking at it on the edge of the sun, it'd be a huge prominence. And again, you could fit probably 8 or 9 Earths from top to bottom here. It is extremely high and extremely huge, as is this one here, several 100,000 kilometers long. Trying to darken it up a little bit so you can kind of maybe see the area in here. That is pretty cool right there. Pretty active little area right there. That's pretty cool. Let's see what it looks like in black and white. Kind of the same. It's really hard to get a good focus on something that you have a lot of heat that's rising, and it gets really, really um, uh, like distorted from the heat rising off of the house or the atmospheric turbulence. Let's see here. Let me check my camera settings to make sure everything is going good here. This is a camera that's being tested at the moment, and looks like it's running pretty good so far. It's been going for almost 3 hours now, and the camera has not missed a beat. We've been streaming for about 20 minutes. We'll probably stream for about 10 or 30 more minutes. This is just a quick view of the sun today, and I'm hoping everyone who has stopped by has been able to enjoy the view so far. It's a little warm today, and I'm just typing in the chat. Thank you all for stopping by today. I can't believe that it's in the high 70s today. All right. Let me know if you have any questions. Throw them in the chat. I'll try to zoom in on an item that you like. I'm having to bounce between the iPad here to look at the chat and see what's going on. It's screen's kind of hard to see, so if you have an area of the sun you want to zoom in on, or in particular you want to grab a screenshot, let me know. I'll try to zoom in on it for you. I'm hoping. Let me take a look up at the sky and see if there's any planes in the area. A couple clouds. There's no planes in the area. That would be pretty cool if we could get lucky enough to have a plane come by and capture a plane during the time lapse. That would be pretty cool. But this is our sun today. The telescope that we're using is the Lunt Solar Systems LS60MT. It's a modular telescope, so you can take it apart, remove the focuser, remove the HA filter. Sorry, I had to get a spider that was coming up onto the camera. You can remove look at the birds going by. You can remove the focuser, remove the HA filter, put the focuser back on, and it becomes a 400 millimeter focal length telescope that you can do visual or night astrophotography with. So it's a pretty cool telescope. Haven't tried that yet, but I will definitely try that in the future. Wow, there's lots of birds flying around today. All right, so let's get another look of the rim of the sun. Let's put this back to normal here. Let's see what's out there in black and white. There it is. Still looking pretty active today around the rim. Now, if these individual big, massive prominences, which we do have some of those big, massive prominences, we have those actually, we have those right now. We have those right in here. There's several of them. There's 1, there's 2, 3, 4, 5, 6, 7. There's probably 20 or 30 of these huge prominences. And if these prominences in this area, in this sunspot here, if it were to produce flare or a CME, it's almost, it's pointed in the direction of Earth. It's this way. So that could affect us in the long run. You know, we could have the aurora borealis or any number of radio issues with large enough CMEs. But, you know, currently there's nothing that's hitting us right at the moment that I know of. I have to go and check the website, but this doesn't look like it's intense enough that, from what I've seen before, really intense. As of like last week and last month, going across the sun, there were these huge sunspots that were going across the sun and just emitting solar flare after solar flare and coronal mass ejections, setting us up for some really cool aurora shows here deep in the South in South Carolina. And I really hope that you've enjoyed looking at the sun today. Oh, you're more than welcome. If I get this right, Zyler. I'm sorry if I mispronounce your name, but yeah, you're more than welcome. And I'm thankful that you're here, and at least willing to learn more about the sun. I do a lot of deep space photography, and recently I've been doing a lot of solar photography, and I really like it. I really like learning about the sun and its capabilities and what it does for us and what it can do and what it will do to us in the future during geomagnetic storms when we have them. It's really, really fun to learn and really cool to watch. Oh, awesome. Awesome. I'm glad I got your name right, Zyler, and I really appreciate you being here. I appreciate every one of you stopping by. The chat is hard to see, so um, I appreciate each and every one of you for stopping by. And if you haven't checked out my channel, Wilfredo's Astrophotography, I just uploaded a new video testing ZWO's new version of their 2025 2600 mm Pro camera. I did a solar time lapse in that particular video, so if you don't want to watch the whole video, just skip to the end. You'll see the time lapse. But on my website, starwalking.org, I also have some images there. A new subscriber, Chris, thank you so much for stopping by and hanging out and being a subscriber. Really appreciate it. We were just looking at the sun today, live in my backyard in South Carolina, and it is a pretty active day today. But thanks for subscribing. And like I say, I just put up a new video. Please go check that out if you'd like. Since you're here, we'll go around the sun again and explain what we're looking at. We are using a Lunt Solar Systems LS60 modular telescope. It's a hydrogen alpha filter we're looking through right now. And it is able to show all the surface features of the sun. And these big rope-looking things, they're called filaments. These big patchy things are called filaments. The white hot spots are active flare regions, and these little small spots are the sunspots. So we'll zoom in on those so you can see those a little bit better, a little bit closer. Let me give it a little bit of contrast so you can see a little bit better there. So now what we're looking at here are these big rope filaments that are connected to the solar surface here, and you could actually drive underneath this thing. Underneath this, that's like a big loop, and it is about 150,000 kilometers high. But we're looking at it straight on, so it's really tough to tell that it's sticking out. But around these sunspots, it's really active, and all these are gigantic filaments. Their prominence is on the edge. Filaments and prominence are one of the same. It just depends on how we're looking at it. Let's get really far up in there. And now you can see around this sunspot. And you can really see the active region in and around that area. So this is where solar flares are going on right now in this hotspot active region. And if there were going to be solar flares, they're more likely than not to come out from a solar spot area, an active region. And we can certainly see the active region here because it's the white spots are the hot spots, and there's no really hot spot over in this area, right? So that's how you know that we're in a hot spot area, just as it is over here. Now, just as we saw this rope filament right here, let's see what it looks like on the edge of the sun. So let's overexpose the sun, and let's bring out those prominences around the edge. So as we can see here, there's some really big prominences here. Now this prominence that we were just looking at a minute ago, when I said it was about 150,000 kilometers, that's about the same as this one, and you can kind of see right through it. Let's tone this down a little bit. So there. Now you can see there's a big hole in it. I hope you can see that. There is, oops, there we go. There's a hole here. And you could drive, if you were able to drive, you could drive right through that. So that's about 150,000 kilometers high off of the rim of the sun. And you could probably, on this one, you could probably fit 6, 7 Earths from the rim to the top of that prominence. But you could, if you had a spaceship that was strong enough and, wouldn't get burned up, you could fly right through that thing. That's pretty cool. Now, earlier, there was some really big regions going on over here. Let's see if we can't get those beefed up. There we go. They're very small, so I had to really overexpose, and I turned the gain up really, really high to show you this. But now this is really cool. This is pretty cool. You've got some plasma coming up off of this solar surface, coming up in a loop prominence here. That's what this is. But as you can see, it's not it's hot. Oh, it's really hot, maybe 8,000 degrees where the solar surface is around 10,000 degrees. But look at this one little spot right here. The one little spot inside of this prominence right here is a focused concentration of the heat inside that prominence that's just coming up and going back down. That is pretty cool because there's some really intense activity going on inside of that area. Now look at this one right here. It's trying to heat up right here where the cursor is. You can see it. It's getting cool and then hot. You got the little spark that's just sparking in there. That is really cool because I don't see that very often. They're usually just really hot or really cold. Excuse me. But this one here, you can really see what it's trying to do there. That is pretty cool. Oh, you're welcome. Yeah, Chris, we're going to go around and I'm going to show you what it looks like inverted. You'll see what that means here in just a minute. Let's tone this down just a minute here. Bring the gain back down. But you can really see these are smaller prominences, but nonetheless, they're still just as strong around the bottom. And then there's a little tiny one off to the side here. Not very much going off on the side over here, but there's some stuff starting to happen out over here, though that wasn't there earlier. There's some things starting to happen over here. And as you watch through time, those things just kind of, they'll do their thing after a couple hours. All right, so let's show you what it looks like when this thing is inverted. Hang on one second. All right, let's get this thing brought back. There we go. There we go. So now you're looking at the sun inverted. So everything that was hot earlier was a white light. Now the hot spots are dark. So now the active regions are dark and the solar spots, sunspots, are white But what this does for us is it really highlights all of this prominences, I mean the filaments, all these cloud-looking features. They look like clouds. These are all of those things that are sticking out on the edge of the rim, the prominences on the rim. They're the same things here, but they're called filaments because we're looking at them downwards. But all these things are just sticking up everywhere. And since this is the side of that's facing Earth, because we can see it, if the sun really ejects it out hard enough to be a flare or a coronal mass ejection, that's really cool because we get to see some aurora borealis if it's strong enough. But let's get zoomed in a little bit so you can see a little closer up on some of those filaments. I mean, yeah, that is really cool. Just look at the richness and the deepness, contrast. Let's see if I can focus up a little bit better here. Okay, let's try that. Yeah, that's a little bit more crisp. But as you can see, the waviness, you see that waviness going on through there? Right now, there's two things. I'm imaging over the top of the house. So it's so hot today, the heat is rising up off of the house and causing that atmospheric disturbance is what we're seeing here. Kind of like when you're driving down the road on a hot summer day and you see what looks like water, the mirage on the road. It looks like heat waves coming up. Same thing here, but it's messing with the camera. But wow, look at that. That's really clear. Look at the sun's surface. It is really cool to look at. And I can't wait to put that time lapse out today or tonight. If y'all just saw that, just go across the screen. There was a bird that went across the screen. Wow, look at that. There's that rope filament we were talking about earlier. There's that really active sunspot. And there are let's get in here really close. There's that sunspot again. Let's see if I can increase the contrast to make it a little bit better. But you can really see the sunspot in there. Now, what's really cool is if you go and Google a solar light bridge, a sunspot can form, and when it forms perfectly, it tries to have this little gap in there, and it looks like a bridge cutting across the sunspot. Now, I can't zoom in there far enough, but what it looks like is there's this little bridge thing that goes across there. If you can kind of see it, there's a dark area in there, and either that's a rope filament that's crossing over the sunspot, or that's a light bridge where the sunspot kind of cuts in half. It's pretty cool when that happens. I don't get to see those very often inside there. That is pretty neat. All right, let's let you see the out of we'll show you the outer rim in black and white, sorry, not in black and white. It's inverted. All right, so let's bring the contrast levels down, back the other way, and now you can see the rim of the surface and all of the prominences around the rim. And now again, the sun is so big, in the circumference of the sun, we could fit about 1 million Earths. That's really huge. And it's about 93 million miles away, give or take. And it's roughly 8.5 minutes, give or take, on how long it takes for the sun's light to reach Earth. And that's why time lapses are really cool to watch. So I really, really want you to go and check out the time lapses that I do here. They're fun to watch. They're just really cool to look at. But you can see the prominences here. Some of them here are escaping. Some of these are really big in nature. A lot of plasma in the air. And what's really cool, when they get like this, when they start to look at that, look at the detail in there. Wow, and this one here is starting to grow on the top. But let's get really zoomed in. Let's get really zoomed in to the one on the side here. Now, for those of you who are movie buffs and you like Thor, and you remember when they zoom in, they fly into Asgard, and it shows the Asgard city. This always, when these prominences get like this, it reminds me of Asgard, how it's got that pyramid-looking feature. And isn't that weird? You know, I'm not trying to throw a conspiracy theory out there, but just the way that sometimes these things form, it looks like a pyramid on the sun, but it's not. It's truly just plasma, and it's being pulled. Um, it's being pulled. No, it's not a black hole. Bujo 24. It's not a black hole. Um, uh, it's this right here is plasma being ejected up off of the solar surface, and then it's being pulled back down by magnetic forces. What's really cool is when these things grow, and let's say this one right here, there's a tiny one right here. If it grows more and it spreads, and let's say it spreads to here, to here, to here, and then it gets bigger in nature, um, like from here to here. See how this one has really sparse. This one looks like it's floating in the air. When the prominences grow in between here and here, and they're all together, it forms. And it's funny what they say, but it looks just like your house. Imagine your house having a bunch of hedges in front of it. They call it a hedgerow prominence, where the hedges, they look like a bunch of hedges in front of a house. So that's pretty cool. Now, I can tell you this, if I were able to zoom in, put a Barlow lens in, zoom in on this one right here. Let's get zoomed in on it. If I were to zoom in on this piece right here, when you do a time lapse of just that one piece, you'll see plasma, these little tiny pieces of plasma. It's not tiny. It looks tiny here, but in reality, it's ginormous pieces of plasma shooting up to that little area and then circling around and then coming back down. And the time lapse may show it go up to it, and it being held there, and then it may stay there for an hour, it may stay there for a week, but then it'll drift its way back down. If it's strong enough, let's say this particular prominence is strong enough and there was enough active region to shoot it away really fast, is what a solar flare is, and it shoots away an astronomical speed, then the magnetic forces aren't strong enough to pull that plasma back in, and it escapes out into space. That's a coronal mass ejection. And if that big blob mass was facing us on the front and it ejected out towards us, that would be pretty cool in the sense of it may cause a geomagnetic storm and give us in the south some sunspots. All right, sorry, I'm going to catch up with the chat here. I saw in my dream that Saturn will collide with the Earth. The view is amazing, though. Oh, yeah. You know, at some point in time, you know, I don't have a background. I don't have any college degrees in astronomy. But, you know, the way that things work is if you hang around long enough and the sun, the sun very well may, you know, collide with us. I mean, planets could collide. Nobody knows, right? I mean, gravity and all the stuff moving around. So maybe billions of years in the future, Saturn may collide with us. No, galaxies are going to collide. So why not planets and stuff? So, but it is pretty cool to watch. Now, I just got a C14, a Celestron 14-inch telescope. Let me back this down just a little bit so you can really see what's going on here. And I'm able to get planets really good. So I just got Jupiter. I just published a Jupiter time lapse. So go and check that out. That was pretty cool. But I'm also going to try to do time lapse on Saturn. Let's see here. Chris says our sun will expand into your red giant. Yeah. Oh, that's cool. Yeah. Yeah. You know, it'd be a shame for us not to be around to see it, but I don't know if I'd want to be around to see that. But it would be pretty cool to see something like that happen. It'd also be pretty cool to watch that. What was that star Betelgeuse? They said was gonna, you know, it was going to do its thing and explode. That would be pretty cool to actually see. Um, it's far enough away, I think, that wouldn't cause us any harm, but it would be pretty cool to watch. Let's see here. So on this, let's see here. Our sun is too small to blow up in a supernova, which sometimes can turn to black holes. Yep. Our sun will burn through its hydrogen gas while becoming. Oh yeah, that's cool. That's some good information. That is pretty neat on how all this works. Let's see here. Wow, let me check out the sun here. I'm looking up here to see if there's any planes in the area. There's no planes in the area, but there is a tree. Unfortunately, where I'm at, I have to, you can see behind me there's trees, and I've got about that same equal distance around me where there's no trees. So I have to plan where I'm going to do this solar time lapse and solar live streams. And right now I've got a huge pine tree, and as the sun is moving across the sky, it's going to move into that tree. So we only have a few more minutes here while this live stream is going to be possible because of the tree situation. It'll be too hot in a billion years. Once the sun starts expanding, that's it for Earth. We have about a billion years left. Oh yeah. Yeah. Can you imagine being on Earth? It'll slowly get hotter and hotter and hotter, but can you imagine if it's going to, let's say, if it was a billion years marking today's date, that it would really expand and blow up. So maybe as it gets closer and closer and closer, maybe half a billion years, the temperature on Earth gets really, really, really hot. You have a lot of sunscreen. I wouldn't want to be around in a half a billion years on this place. But is there any regions of the sun that you want to see again, in whole or in part? You're driving from Nashville to the Smoky Mountains for Christmas. Thank God the sun is out. It was dreary and misty in Nashville. Oh man, yeah. The mountains would be nice right about now. And I'm glad we have a little bit of sun today. So, luckily you do have the sun out today. And luckily we have it out here, but I think it's going to, oh, there's a plane. Oh, sorry. No, it's going to miss it. I think we're going to have clouds the next couple of days, I think, here. But I'll go around the rim of the sun one more time. I'll get zoomed in. I'll show it to you in black and white one more time. And then we're probably going to run into that tree. It'll be time to cut this time lapse off. This solar live stream. But there it is right there in all its glory. Let me turn off the solar colorization so you can see it in black and white and put some more contrast in there. Let's hit it with a little bit more gain. There we go. Let's see if I can get it focused in a little bit better now that we got it in black and white. That's looking really good, though. You can tell when it gets really bad. The focuser on this Lunt is not the worst. It's not the best. If you want the best, you gotta spend like $600 to upgrade to a focuser that's really good. However, when you spend $2,000 on a scope, you'd figure it'd come with one of the best focusers out there, but no. Anyway, look at that. That's really, really cool. There's still that sunspot. There's that filament. These filaments look like they're growing in size, expanding out from this sunspot. And right here, there's a little tiny area that looks like it's getting to be more of a hot spot. So I'm going to contrast it up to show it a little bit more. So it's going to be a little darker for a second, but right there where the cursor is, that's probably going to be some solar flare activity going on here in a little bit. if the activity keeps up. Looks like it's starting to get really bright and flashy in that area. It looks really hot. That is really cool. All right, let's move up to this one here a little bit. Whoops. Come back. This is a really cool looking region here. It's a round hotspot region. Now, what would be really cool is, yeah, get some cereal. I need to get something to eat too. What this is really cool looking is this may turn out to be a gigantic sunspot in the making, where you've got, now I don't know this for sure, but this is how it's looking to me. It looks to me as if you got a round ring, and I know it's really hard to see because it's a lot of atmospheric this disturbance going on right now, but there's a round ring here, and it looks like it could separate this plasma and make it lift up. If that does, that would be one big sunspot. That would be really huge. I don't know if that's the case, but nonetheless, that would be pretty cool to see if that took place. If that turns in to a big sunspot, because you already got one there, 2, 3, it's like a fourth going on. And if that could converge into one gigantic one, man, that would be cool. That would be really cool. All right, we're going to go a little bit of black and white here. Let's see if we can get this thing. Really overexposed to the contrast, so we can see those filaments up really close before we go around the rim one last time. Wow, looks like a little tiny flare going on right there. That's pretty cool. That wasn't there earlier. And now that we're looking at now that the sun has been rotating as we've been sitting here watching, and you can see if you look close enough, you can tell that this area right here, is almost like it's not a filament anymore, because we can actually see it sticking up like a sore thumb. So this is now like a prominence, because you can see it rising up from the surface. That's pretty cool. That is pretty darn neat. But you can see all the waviness going around the sun. That is all of the heat coming up off the roof. I could just sit here and watch this for hours upon hours. All right, let's look at the rim one last time. Look at these really cool prominences. Oh man, that rope one right there. It looks like it got more well defined. It looks a whole lot better. Yeah, let's see if I can focus in on that. All right, so what I'm going to do also is I'm going to adjust the Etalon filter. So give me just a second. This may cause an issue with the tracking and the focus, but I'm going to adjust this Etalon filter to see if we can't get this prominence to show better. Oh, wrong way. All right. That's better. Ooh, wait. Oh, there's a big old plane. Oh, it's going to miss it. Wow, that'd be so awesome if we could catch that one. All right, now let me do a focus on this again. See if I can't get this prominence crisp. Hey, look at that. That looks pretty good. Yeah, look at that, man. You could really drive up through there. That's a good one now. Wow, that's pretty cool. Let's put a color to that and see what it looks like when there's color. Let's get rid of the piece. Let me bring, I gotta bring this back. Oh wow, look at that. Look at what we did when I changed the Etalon filter. The Etalon filter made the surface stick out a little bit more. Well, let's go back to that. Let's get focused up on that really big prominence right there. See if we can't get that coming in. There we go. Oh, wow, look at that. Looks like a huge fireball off the side of it. That is pretty neat. Look at that. The roof is on fire. Yeah. Yeah. Yeah, that roof is on fire. Look at that. That is, man, that is like a big plasma fireball just sitting right there. Now that would be one awesome time lapse if you were to sit there and watch that one. That is cool. You could just sit here and live stream this one area for about an hour. And over the course of, let's see here, we've been live streaming for 57 minutes. And I can tell you that in the time of 57 minutes, if you were to go back and rewatch this live stream, go to the beginning where we talk about this prominence over here on the left top side, you'll see that it was never really clearly defined. I mean, it had some stuff in the middle, but this little piece over here, it was that one that had that little hot spot in there. And now look at it. It's really grown into that cool looking flame. Yeah, plasma bridge. Yeah, that's a good name for it, Chris. Plasma bridge. Oh yeah, the bridge to Asgard. Yeah. that that is insane right there. That's cool. One of these days I'll see if I can't do a actual time lapse of something like this and then play it in fast forward so you can see it like that. Excuse me, or even put a Barlow lens in. Sorry, I'm looking at I keep hearing these planes fly over and oh, there's a big cloud. It's starting to get cloudy. Um so one of these days I'll do a time lapse like that. Man, that is pretty cool. I could let it sit and watch this thing for hours. That's icing on the cake right there to be able to see a huge plasma just prominent sitting just off the top of the solar surface. It's not really connected. I mean, it is connected, right? They do great work out of Kansas City. Oh, yeah. How many Earths can fit in that fireball? Okay, so I would say uh, one, because the Earth would be almost the size of just a triangle piece of the pointer. So one, two, three, three and a half, maybe? I mean, ish, three and a half, maybe four ish. It is mega huge though. Huge. Wow. I want to say while everyone is here, uh, thank you. Thank you very much for being here and hanging out with me and checking out the sun today. It really means a lot that you took time out of your day to come hang out with me and do this. So it is very, very much appreciated. Truly, truly. And it also helps my channel grow by getting people into a live stream and also uh, to grow my channel as well. Um, the Tankla. Sorry if I get that wrong. Great shots. Thank you very much. Yeah, this is a huge solar prominence, and I'm going to call it a plasma ball, even though that's not what we call it, but it's just a big prominence, a big ball of plasma that we've watched grow over the course of, it's almost been an hour now. And this is a huge solar prominence that is about 150, maybe 125,000 kilometers high from the surface to the tip. And you could actually drive through there. If you were able to drive through there, we could probably get, that's 1, 2, 3, 4, 5. There's probably 20 Earths you could fit inside this whole prominence here. The Angry Astronaut. I haven't heard of that one. I'll have to go and I'll have to check that one out. Yeah, hydrogen alpha rules the whole damn universe. Yeah, it does. And there's nothing like looking at the sun in hydrogen alpha. Let's spin around this rim real quick. There's a pretty cool little feature just hanging off here to the side. There's another little area there. Ooh, the one on the bottom. The ones on the bottom look like they're trying to grow a little bit from before. Let's get a around the rim real quick, and then a last look at that. Ooh, now this one's growing here. This is a really cool looking loop right here. We'll get zoomed in. You can see it right there. Let me boost it up just a little bit. There's that loop. You can see it. A clear loop prominence right there. That's huge. Not as big as the other one, but it is huge nonetheless. All right, let's look at the entire solar surface. There we go. Let's pull the gain back down. Get it back down to seeing the solar surface. Let's let you see it in inverted. Oh, did you see that? That was so cool. The bird just went through. Tell me y'all saw that. Give me a thumbs up or something in the chat that you saw the huge bird fly through there. That was cool. Just at the right time. Got it exposed just at the right time. That was cool. How cool was that? Oh, yes, I just saw it. I didn't see it the second time. Yeah, that is so cool. That is so cool. All right, let me get this thing, let me get it to where it needs to be so we can get it, exposed right to see it this way. All right, so we're going to look at the sun right now, inverted. Oh, that's cool, Chris, man, that's awesome. I appreciate that. Just being here and trying to get other people to watch the channel and watch the videos, that helps a lot too, because that drives a lot of watch hours, and watch hours turn into basically turns into money that can purchase the channel. That's how we purchased several solar filters, cameras, and telescopes for this channel. So it is greatly appreciated, and thank you. That's amazing. I really appreciate that. Here is the sun again in the inverted, so you can see all of the solar filaments. These are the filaments, these long cloud-looking features. That's what those are. Let me get it refocused, because earlier we were focused on the outer rim. All right, there's that. Buc-ee's. Oh, I love Buc-ee's. They got good barbecue. So there is this. The dark areas now are the hot spots. So that's the active regions. The white spot is the sunspot. And there's those filaments, the rope-looking structures. As you can see, there's a bunch of cloud-looking features on the sun. And basically that is filaments. Filaments, again, and prominences are one of the same, except this depends on how you look at the sun. So when we're looking directly at the front of the sun, They're called filaments. And when we look at the rim of the sun, he just barely got the exit there. When we look at the sun directly on, that's when they're called filaments. But when we were looking at the view of the sun from the outside rim, those are called prominences. So here we go, looking at the sun just in black and white. And now you can really see the active regions. These are the active regions. And this one right here, this region right here, I have the cursor. That region was not bright at the beginning. And what's really cool is if you go back and watch this time lapse from the very beginning to when it is right now, go to the very beginning of the time lapse, of this live stream, and wait till it gets to a view of the sun. So you'll see a view of the sun like this, or you'll see a view of the sun in the very beginning like this. And when it's like this with the yellow color, the sun color, take your cell phone out and take a picture of it and note where all these white spots are. And then at the end, you can go back and take a picture at the very end of this live stream, do the same thing, and note where the hot spots are. And you'll notice a difference in the sun's active regions and where the flares are going on. That's pretty cool. Let me check where I just heard a plane. Nope. It's close, but we missed it. All right. So there is the view of the sun with the solar colorization. Let's look really close. Only got just a few minutes before it hits the tree. Sorry if I'm talking faster, but I'm going to try to get you a view of the sunspot up close. Let me get it focused up for you. Hang on just a second. Try to get it focused. We make it darker with better contrast to get a better focus. There we go. There's a sunspot. That light bridge is still trying to go in there, but you can see these big rope filaments. And there's the filaments extending out from the, there's like 1, 2, 3, 4, 5. There's hundreds of little filaments, or they're not little, they're gigantic, really, in that area coming out from that sunspot. But how cool is that? Now let's look at the rim of the sun. Let's bring the exposure up just a wee bit. There we go. Now let's bring the gain down just a little bit so we can look at that. Now all of those rope things that you were looking like on the sun, now on the outer edge, they're called prominences because of the way we're looking at it, because they're not facing the earth. Everything on the rim is going outwards. So let's get up real close to those again. And there's the one that looks like Asgard in the movie Thor. That's pretty cool. Let's get it toned down just a little bit so you can get a little bit better definition in there. There we go. There we go. That's pretty cool right there. Pretty neat. Onus says it takes 10 million Earth years for light to make it to the outside of the sun. And and 8 minutes to hit to Earth. That's right, yeah. Yeah, roughly 8 minutes for the light that's facing Earth to hit us. That's some pretty cool knowledge right there. It is pretty neat to pick up on all that and learn all that stuff. Now here's that thing from earlier. Let's get it boosted up just a little bit more. There we go. That's what we started off with right there. A big plasma ball sitting there off the solar surface. Man, that is just so cool. Well, I'm glad you did, Chris, make it to the exit. And I could go for a Buc-ee's barbecue sandwich right now. Now I'm gonna tell you this right here. I'm pretty sure that if you were to look at the beginning of this live stream feature till now, the bottom here has grown quite a bit in intensity. Pretty sure of it. And off to the side here, let's beef this up. Look at that. There's some, the sun is really active. It's really going on. And look at that rope filament right here. Sorry, it jumped on the side of the screen here. Look at this one right here. It's going out into the plasma, is shooting off and coming back around on this little loop right here. Look at that. It's got a little hook, comes up and goes around. This side has gotten way more active over the last hour. That is pretty cool. Oh, the top of the sun. Oh, come back. Sorry, it's because I forgot it zoomed in so much. There we go. Look at that. That one's reaching pretty good. The top is reaching really good. We had to really boost the exposure up to see that in better detail. Wow. Now, if y'all want to see something neat, I'm going to go back to the surface of the sun so you can see the whole sun. We're going to take off the sun color here. We're going to get it on a normal view. And what I'm going to do is I'm going to show you how this, I'm going to give it just a second so the live stream will catch up, because we're so close to this tree. We're going to have to end the live stream here in just a minute. But I wanted to show you how well this solar telescope works. It's pressure tuned. There's a knob on the side of this thing, and you tune. The more pressure you put on the filter makes these filaments show up, or the sunspots show up either better or worse. So what I'm going to do is I'm going to adjust the Etalon filter, and you'll watch the screen. You'll watch these filaments go away. The sun will get brighter, and then these sunspots will just look like sunspots. Okay, here we go. I'm going to adjust it, and you'll see it. It's going to move around quite a bit, but I'm going to adjust it so you'll see it. See, it's starting to get brighter. Starting to get brighter. The surface detail is changing. See how it's changing? It's getting really, really bright. It's getting really, really bright all the way to the edge. All right, so now it is completely bright, and all you see is a sunspot. That's because what I've done is I've tilted the Etalon pressure just enough to where all we're seeing is these sunspots. Now look at the difference. The difference is quite different. Ooh, there goes was that a bird or a satellite? I think we just saw a satellite go through the screen. I'm not sure. It was moving pretty fast. I don't know. It could have been a bird. Time for some ice cream and bathroom break at Buc-ee's. I'm going to keep up with you. Oh, thanks, man. I really appreciate that. Yeah, that would look good on the big screen one day. Thank you so much, Chris, for being here. Thank you so much. Drive safe to your final destination. Thank you very much. And help spread the word. Spread the channel to all your friends and family. If you can, if you want to. I really appreciate that. So here's a different view of the sunspot. Now watch what happens when I adjust the filter back up. See how the surface is changing? Look at the surface. It's starting to actually have more definition. All right, so now I gotta boost it back up because we changed it. See how it's starting to all come back? And if you go too far, it just goes on the other side. So you got to get the pressure just right. And when the pressure is just right, and everything is just right, the sun looks really cool, like it does right now. But there we have it. There is the sun. I'm going to give it one last view like this if you want to see it. And then we're going to have to end the live stream. I really hate to go. I'm glad you're back, Zyla. There was some pretty cool stuff in there, so go back and if you can watch the stream again. We adjusted the filter to show you a different way of looking at the sun, and I'm almost to the tree where the sun's going to hit the tree. So I'm going to have to end here, and I got to go in and get me something to eat as well. But I can't thank you all enough for being here and watching the live stream. Thank you. And I really appreciate you for being here. Spread the word. Get your friends and family in to the channel. Oh, you're watching but eating cereal. Yeah. I need cereal. Sounds good, but I'm telling you, Chris had that Bucky's barbecue sandwich. Sounds really good. But the more people that we can have subscribe to the channel, just so you can watch the stuff that I put out, makes the channel grow. And if you're really interested, and this is the cool part, if you're really interested in solar and you want to do a picture of by yourself, meaning you want to create a solar image yourself, if you will go into my channel and look for, or even go on the YouTube site and just Google how to process solar images. And one of my videos is going to pop up. It says, I believe it's how to process H-alpha solar images like a pro or something like that. You'll see it's a picture of me standing there. Inside of that video, if you click in the details, I put data on there so you can actually go in there. It's hosted on my Google Drive. You can download that data. I actually show you and teach you how to process solar images. So it'll tell you which programs are free to download, how to do it. It's a tutorial, walk you right through it, and you can use the data that's there, process that solar image, and you can create a sun image just like I did for practice. So that's there. I'm in the process of trying to do another one and upload more data. But just like in the beginning of this live stream, the internet was very weak. I live out in the country, so I use Starlink, and sometimes Starlink upload is very difficult. So I say in that live stream or in that video that I was going to upload like a terabyte of data. Well, it basically broke my Google Drive. I had to pay more to get more space. But then the internet, it was taking, 4 weeks to upload that data. So I had to cut it back to just a little bit. But there's enough data on that video in the description, everything you need to create your own solar picture. So check that out. Yes, I love my Starlink. It works great. Sometimes it just doesn't have enough upload speed to upload my videos, but it works great for download. But again, thank you all for being here. I really appreciate it. Thanks again, and help spread the word about Wilfredo's Astrophotography and solar imaging. And I'll try to do this a lot more. If you go to any one of my, I'm on YouTube, I'm on TikTok, I'm on website, Instagram, and it's all Wilfredo's Astrophotography. So if you want to email me, just go to my website, starwalking.org, send me an email. If you want a specific video or a how-to video, shoot me a DM on Instagram or TikTok, or even shoot me a message on one of my videos, comment on one of my videos in YouTube, and we'll make something happen. But thank you so much for being here. Have a wonderful Saturday. And again, from the bottom of my heart, I really appreciate everybody for stopping by, and each and every one of you who watched this live stream. Thank you so much, because in the end, the more people that watch this live stream equals watch hours. The more watch hours makes it possible for this channel, our channel, to purchase more equipment to do cooler and more awesome things. So appreciate you. Thank you so much. See you, Zyler. Thank you so much, Chris. Um, the Thankla and the Onus. Thank you so much. If I missed anybody else, I apologize, but thank you so much. Y'all take care. Have a wonderful Saturday.